Hey YouTube, how is it going? I hope all is well. Today we are going to do just a couple things a little bit differently. First and foremost, we have a new build. And with the new build means that we also need to then therefore do a schematic. So we're going to go through today and we're going to make a schematic for a brand new build. I hope you are excited. Also, I want to if you didn't watch the last video I did, then you probably missed out. And I had mentioned that this build that we're working on right now is probably going to be a raffle / giveaway build, which is to say that I'm going to take you through the entire process of building this thing, the cabinet and all, the whole nine, the whole kit and caboodle. It's going to take some time, but we're going to do it. We're going to show you all the steps, how we do it. And then at the end of it, it'll be either raffled off or given away. I haven't decided how I'm going to do that yet, so don't hold me to anything yet at the moment. I just want to kind of get you informed of the fact that this thing is not going to stay in my possession. Come hell or it's a real show already. Come hell or high water, this thing is going to leave my shop and get into someone else's hands. I am leaning more towards the raffle for two reasons. Reason number one is accountability. All right. I can quantify everything. There's no second guessing. There's no way to really cheat it, right? So everything has a level of accountability. The only thing that's a downer is that you probably have to go to some link, which means you may have to sign in and create an account or something like that. And then, of course, some amount of money has to exchange hands, right? But that I feel is going to be the fairest and most secure way to guarantee fair results. That. If I do it the other way, where you do the whole like, comment, subscribe kind of thing, and maybe you have to put like a particular comment at a certain time in, I just don't know. I don't want this to go to somebody that cheats the game, right? That swoops in, isn't a real subscriber, doesn't really care about what we're doing over here. They just want to get a free amp out of it, right? I want to try to avoid that kind of thing. I also know that the possibility for me to make more income or more profit on this amp than I need to actually build it is a potential. So I'm also looking at the possibility with the raffle idea that anything that's superfluous to the cost of building the amp will then go away to charity. And I'm thinking off the top of my head, the charitable organization that pops to my mind first is the Mr. Ballin Foundation. I can't remember exactly what he calls it, but I like Mr. Ballin, and I like his organization that he does. So I would like to give to that if that's the way to go. But I'm thinking also too that if basically whoever wins the amp can decide which organization the proceeds would go to. The wheels are turning. I haven't locked anything in yet, but I'm leaning towards a raffle for the fairness and just for the opportunity to give more back than has gotten put in. You know what I mean? That sort of thing. So with that, let's talk a little bit more about what it is that we're working on today. So we are building a schematic for a new amp that is basically going to be a 5E3 modified. I can't even say it's going to be a 5E3. Realistically, it's going to be a single input 5E3 ish amp. It will have a cathodiene phase inverter. It'll have 6 V6s. It'll produce about 18 to 20 some odd watts, and it is going to be a monster. It'll have beautiful cleans if that's what you're looking for, and it'll do the nice, tweedy thing that everybody loves about tweed style amps, right? That's what we're going to do. That's what we're going to make today. So, without any further ado, let's get ourselves over to here. All right, so what you can see here is Schemit. If you don't already, and never mind the background music, that is there intentionally, try to drone out some of my droning. But okay, so Schemit. You got to get Schemit. Just go and find it on the interwebs. Make yourself an account. It is this is, as far as I can tell, the best program for what we're doing here that I can find. Now, what I can tell you is that you are not going to have all of these guys here that I have. When you create the account, you got to create favorites. And basically what you do is you go to something, you find a diode or whatever, and then you click this as your favorite, right? That's how you do that. But you're going to have to go through there and do that and find those things. And there's about 20 items. It's about all it takes to pretty much build an entire amp, right? So once you find these things, you're going to be good to go. Now, I kind of work in reverse. So I like starting with the power supply first. And to move these things out, you have to click and drag. So you have to left click and then drag it out. Now, Alt plus R will rotate them. And then you also have Alt plus H and Alt plus V, and that will do a horizontal and a vertical flip. So if I hit Alt V, you can see it just vertically flips it. And if I hit H, it'll just flip it the other direction, right? So for the most part, you don't really need to worry about that because Alt R will just rotate it around. So you need to find a place where you want to put this thing, and I'm going to stick it right there. So next thing in line that we're going to need is a fuse. And I said that I usually like to start from the output first. So what I tend to do is design the output first, and then I go from there to the input. But I label everything from the input and then do the output last. So just be mindful of that. It's just the way I do it. It doesn't necessarily mean that is the way it has to be done or is the way to do it. So just that's all. So we're going to find a little place for these guys here. It's helpful to try to keep everything in line. And I'm going to just click it into there. And we just need to know that it's going in there, right? It doesn't really matter all that much. And then we're going to do the same for this guy. And it'll kind of just does what it does. You do have to be mindful when you start laying these things out because you cannot just add another line somewhere. You have to go from a component into it or a component to component. And it can be challenging, especially when you start building a bunch of stuff. So I'm going to use this one here. I don't use necessarily the correct transformers. This is the only one that has 2 in and 4 out, right? And I don't worry about the heater supply so much, but this one would have the primaries or the secondaries for the HT side and the heaters for the HT side. So it works well for what we're going to be using it for today. So just that. That's really it. So this one just makes it the easiest for me. Now you saw here that I can make it go a different direction. In order to make it flip another new direction, you left click and then it'll allow you to alter another direction on it, right? Okay. So that's how you kind of do the line thing, and I'll show you more about that later on. But now what we're looking for is this guy right here. I am using a solid, or not solid state, a tube rectifier on this build. So it is, you can do whatever you want, but I'm using a tube rectifier. So the way that this one works is these are the plates and this is the cathode here. The cathode is what actually supplies the HT. And we have this guy here for reference to kind of see what I'm talking about. So this is the cathode here, and you can see the HT rail comes off of the heaters. A little bit different. So the high voltage comes into the plates and goes out of the cathode. I guess you can call it the cathode. I don't know. It's technically the cathode. But anyway. And then we're going to go bloop. Just like that, and then we're going to do the same thing here. Bloop. All right, so now we're going to take this guy and move it up there. It's not going to be V1. We'll deal with that later on. But this guy here is going to go like that, and then this guy is going to come out and around and like that. All right, so I've connected these together, which may or may not work appropriately, but we're going to worry about that in a moment. So first, we need to start getting some components out onto our thing. And we're going to start with our first capacitor, which is our resistor, or reservoir, excuse me. Went a little too fast. Now, once you get a component out there like this and you know you have multiples that you need to do, Control-C, Control-V. standard Windows things. If you're on an Apple machine, obviously it's Apple, A, C, V, and all that fun stuff, right? Now these guys here, you want to try to get some distance between them, but you also want to try to find some sort of spacing that you like, right? So we're going to go, all right, whatever, 1, 2, 3, 4, 5, 6, 7, 8. Cool, right? We're going to just say 8. We don't know what it needs to be, but we're going to go 1, 2, 3, 4, 5, 6, 7, 8. It's just a generic one. 1, 2, 3, 4, 5, 6, 7, 8. All right, it's a number. And we may need to go one more to make it so the spacing, it doesn't matter, right? Just pick a spacing. So we're going to put this guy out, and we're going to rotate this guy. And then we're going to go Control C, Control V, Control V. All right, and then we're going to move him into place. And we're going to do something like that. So we're going to keep it off of this line right here, right? Because that's where it's all going to start connecting to here in a moment. Boop. And then we're going to take the same thing here and go boop, right? Does that make sense? It's all starting to make sense here. All right. Now, we've got our 3 resistors. These are our dropping nodes right here. And it looks like one of these is a little off. Maybe not. I don't know. Whatever. We'll deal with it later. So we're going to connect it to here. And that did what it was supposed to. Then we're going to connect this one out. I'm kind of speeding through this, but I'm also trying not to speed too much. So then we're going to take this and go up. Same here. Yeah, they're not centered is more or less what it comes down to. So this one, it needs to go over 1. So watch this. I'm going to take these guys. Ooh, you dirty little thing. I'm going to Control plus this one in there. And I don't know, whatever. We can also take this guy and move it over 1 like that. So, and this one needs to move over 1 as well. There we go. That looks a little bit better. It might not actually be right, but it's close enough, right? We get the idea. So now we need to put in some voltage rails. So we're gonna I did click and drag, 1. So we're gonna go Control C, Control V, Control V, Control V. So now we got 4 nodes, right? These ones here, you just kind of need to find a spot for them that you are happy with. And I'm going to call that good enough. So this is not going to be super duper pretty. I'm just going to kind of speed through it. All right, then we're going to connect these down to here. And these are now our nodes. These are our voltage nodes, if you want to call them, whatever you want to call them. These are our nodes. All right, so we can label these things, so it's probably good to label them now. So we're going to go, I need Shift A to make it actually go, that. And then we're going to move it up to there. Same here. Shift B. And you can label them pretty much however you want, realistically speaking. I try to go things in why on earth would you do that? All right, there we go. I try to label them as it goes left to right. That's really all it comes down to. So you can do it however you want. If you want to call them X, Y, Z or 1, 2, 3, you can do that. So now we got A, B, C, D. All right. Now what we also need to do is this. So we're going to take this guy and we're going to go up there like that. And then these guys need to come down. And now we need a ground. So we're going to pull this guy in right there. Doop. And we need to connect that to there. All right. So this is just showing schematically. This isn't necessarily how you would wire the grounds together, but this is showing schematically how this would all kind of work out. There you have it. Now we have our power supply done for this amp. Wasn't that quick? Wasn't that easy? We still do need to label all the capacitors and resistors and whatnot, but we're going to come back at the end and do that. But I can already tell you that we need to do this for them. So what we're going to do is go 1, 1, and we're going to go 3, 3. I don't know. I'm just picking numbers. It doesn't really matter. And it did it to me again. There we go. 3, 3, 3. Whatever. Yeah, I'm just putting a large number out there because these are not going to be C1, 2, 3, and 4 and all that. They're going to be like some other large number. But not what we're working with here. So you cannot label the same thing twice. It won't let you put, C 33333 again, or 444, whatever. It won't let you do that twice. So if you put out R1 out there and then you put another R1, it'll tell you no, you can't do that. So now we're ready to start working on the actual amplifier itself, and I'm gonna say like right. Yeah, it's not exactly where I want it, but whatever. That'll work. All right, so we just kind of got to pick like a plane to work within, and I'm gonna try to do this one a little bit tighter than is typical for me, because we're gonna run out of space here pretty quick. All right, so we got that, and we need a grid stopper resistor. So we're gonna take this guy and rotate it and put it in the right plane, something like that. That'll work. All right, now we need a dual triode. So I am going to use my parallel triode in the front end of this thing. That is kind of the thing that I do. So I want this guy to like go right there, which will allow me to get this guy just a little bit close. Yeah, right there's fine. All right, so now what we're gonna do is connect it there, and then we're gonna take that, connect it there, and then this guy is gonna go and connect. Excuse me, goodness, I got the burpees. My apologies. I've got the Dr. Pepper. As always, a drink of choice within arm's reach. Okay, so we're kind of banging through our first gain stage here, and we need to create a loop around here. So we're going to do that by going like this, and we're going to go click. And of course that V2 is in the wrong spot. Put it there. All right, and then we need to make our plates also come together. So how do I want to do that? We're going to come up a little bit higher than normal because so there's that. Now we need a couple more resistors, so we're going to go back down here. So this is going to be our cathode resistor. Now I usually label things so it's, you can see it started with R1 and that's R2. This is R3. So the next one in line will be R4. So if you go Control C and then Control V, as long as you do things in order, it should maintain that order from this point on. So that'll be nice and cool. So we're going to do that and click. There we go. And now we need a polarized capacitor. And I'm going to do Alt H. There we go. We want it on that side. And I'm going to do that. All right. So these do need to connect together. And then they'll T into these. Boop. All right. So we can pretty much complete this circuit here. So what I'm going to do is take this end of it here. And I'm going to draw it all the way out over to here, and I think I need to go down a little bit further. So hold on a second here. I'm going to go down just a little bit further. I'm thinking of the future. Future Luke is at play right now because he knows that we're going to wish that we had more space later on. All right, there we go. And then we're going to need, where did you go? Where did you go? I keep missing it. That one. I want that one. I want him right in there somewhere. And that'll work. Now I'm going to go up one. Ta-da. All right, there's pretty much our first stage. Now this is going to be our D node. Now if you just copy that node right there, Control C and then go Control V, it will take the D with it. Get your mind out of the gutter. I know what you're thinking. Oh, there we go. Come on. Oh my goodness. There we go. Haha. There we go. So there's our first stage. Now we need a coupling cap. So let's find where I got those guys at. I think it's down here at the bottom, isn't it? Yep, there it is. All right. So we're going to take this guy. We're going to rotate that one around here. And we do need a second one. I'm going to put the lower one on the bottom. So I like to keep things in order. So I will go top or bottom to top when I lay things out because it just makes it a little bit cleaner and easier. Let's see here how I want to do that. I think we're going to go right in there. We can move these up and down a little bit once we get a little bit closer. And I want that to go right there. And then this one will actually go up to there. So this one is, you can kind of see what's going on here. I'm creating my little base cut circuit right now. So the way I do it is that this is my primary one. So this one's always in circuit, and that's the lower of the two values. And then this one here is our sail over capacitor, so that one will be used to bypass the lows around this guy, or basically turn this into a parallel capacitor, which increases its value. All right, so that's what we're looking to do here, is to make it so we can vary how much bass goes into the next stage. It's like a low cut filter, but it does a cool thing, right? It does a really cool thing, in fact. All right, and I'm going to need a little more space than that. So now what I'm going to do is do this here. So that's going to go click, and this one's going to go click, and then this one is wrong. I did it wrong. Hold on. I got to undo what I just did. We need to go out one more with that guy, and maybe go in one more with this guy, because we need this one to go up there. My apologies. There we go. Helps if you do it right. Now, this is not wired correctly. If you do it like this, it will not work. But it's just a lot easier to put it in the circuit. Just caveat emptor when you're looking at these things. If you find a schematic on the interwebs, make sure you double check everything first, because that does not mean that they are correct. And I do things purposely for me, because I am not worried about certain things. I know how this circuit works when it's in the amp. I do not care what it looks like on the schematic, because this part isn't going to be on anything I deal with later on. When I put it in the amp, it just makes sense to me. So unfortunately, it's not helping you guys at all in that regard, but just be mindful of that kind of stuff. And there's already something here I'm finding I don't like, so I'm going to move that up one, and I'm going to move this up one. And is that in line? Yes, that is in line. I like that now. Okay. So there is some liberties when you move things around. If you move one thing, it'll move the node with it generally. Generally. Not always, but generally. All right, so we do want to have a grid stopper in this amp. So I'm going to put a grid stopper in there. And click, if you wouldn't mind. It's so stubborn sometimes. There it goes. All right. And I think I can just basically move that in. There we go. All right. So now what we're going to use is a single triode. And the reason why we're going to do just a single triode is because this one has a cathodiene phase inverter. So it's a little more difficult to do the circuitry when you've got two different things kind of going on. So I'm going to use a normal triode here. And man, I hate how they put those things up there. All right. And then I'm going to connect that. It's best if you connect those things first before moving them in like this. But just in case, it's always wise to do that. Now, do remember this one is going to go to ground in a minute here. So now we need another resistor that goes to ground. So that's going to be this guy. And then we need another capacitor. So if you do things in order, it will kind of stay in order, which is kind of nice. And we're going to Alt-H. We want that to go that way. That looks like we got the right thing going on there. Click, and then click. Kind of see what's going on. It's on the same plane here. Everything's kind of in the same plane. We like that. And I think what I can actually do is this. Watch this. Ooh, if I get one more, will it do it? Yeah. But see how it kinked it a little odd? Excuse me. So if you select that and delete that, then we can make it look... if you wouldn't mind, thank you. Oh, come on. There it goes. More normal. I like it. So now everything's kind of in the same plane. I don't know. It just makes it look pretty, right? And it gives some space. Sorry, I'm a little retentive when it comes to some things like that. All right, so I want this thing to line up proper like, and I think that is correct. All right, so this one is going to be part of our C node. So we're going to go Control C. We're going to put that guy up there. Click, click, and I'm pretty sure that is lined up. It is. And bloop. There's that. All right, now we got the plate that's going to come down just like that. Now what we can do is actually encapsulate everything over here. So actually, I'm going to wait on that, because we got more stuff coming in here in a minute. So let's work on getting our coupling cap in first. So there's that guy. We're going to rotate it around. I also kind of have this circuit in my brain already. So it's not like difficult for me to understand what's going on here. So I apologize if I'm going a little bit fast for some of you. Just understand that I do kind of I already kind of know this circuit in my brain a little bit. So my apologies. 1, 2, 3, 4. And we need to come out a little bit with this guy. There we go. All right, so now we need another triode. So, bloop. So now we're getting into the cathodiene phase inverter here, right? So we're going to get this guy somewhere. Yeah, we'll put it right there for now. All right. We know that we're going to need a grid leak for this guy. So this guy is going to go somewhere in this realm. We also need a cathode resistor down here. This is our tail resistor, if you will. And then we need the actual cathode resistor, which is also known as the biasing resistor or bias resistor. And then this guy up here. So right in there. Okay. So let's do this. So bloop. Now, generally, some people will put a grid stopper in here. I'm not going to show it because that's not exactly how a 5E3 is done. But I would probably put a grid stopper in there. Usually it's a higher value, like 470K up to about 1 meg. So basically you replace that wire with another resistor. When I build this amp, it will have something more akin to that kind of built into it, just FYI. So things are going to be a little bit different here. So I'm going to connect that up first, and then I'm going to shrink it in one. And then this guy, we're going to bring it up to there. Perfect. I like that. That'll work. And then this guy is already in line. We like that. So this is our grid leak here. And this guy is going to go right there. All right. So this is our grid leak / grid reference for this tube. This is what helps this tube stay where it needs to stay, right? Makes sense? All right. Now we're going to go up down to our plate here. Just like so. Sorry. Probably shouldn't have done that, but you know, whatever. Control C, Control V. And that looks good there. So again, these are on the same node because it's technically the same tube. All right. So this is still one triode here. It's just these ones here have been split up. All right. Does that make sense? I hope it does. All right. So now we need a couple more coupling caps here. So we're going to go, well, first and foremost, I want to rotate it. And then I want it to be down there somewhere. Control C, Control V. We want this one to be up here somewhere. So we are going to have a tone control, but it's going to be a late stage tone control, if you will. I'm in debates on how I want to do this right now. I'm going to go a little bit wider out to give some space. So we're going to end up with the power supply kind of splitting everything up, right? All right. So these do connect more or less straight to... Do I want it to go like that? Yeah, I do. Like that. And then this one's going to go right up to the cathode. It connects directly to the cathode. So let's go back to here for reference, okay? So you can kind of see what we've got going on here. So this is that part of the circuit that we're working on, except for we're drawing this up off the top. And this is that coupling cap that we just drew in right there, okay? So this is our tail resistor here. This is our bias resistor we spoke of. And then that's our 1 meg grid reference, or whatever you want to call it. All right. So we've got that. Now I am going with a late stage tone control, as I had mentioned. So for that, what we need to do is put in something like this. We're going to put them there. And then I need a capacitor. Does not need to be polarized. And that's going to be, we'll put it right here. Because why not? All right, so the way that this is going to work is like this. I'm going to make it really, really tight because I want to have some space over here for everything. Space is importante. All right, and I'm going to wait to draw all this stuff in right now. Now what we need is our grid leak resistors. So I'm going to put a couple of grid leak resistors. We're going to go Control C, Control V. Now these guys here are what set the bias for the tubes. Not the bias, excuse me, but the grid reference for the tubes. And there is a practical value that we can use for this, but we'll come back to that in a minute. For now, I think everything is looking acceptable. Okay, and now we will put in our grid stoppers. So we're gonna. Oh, I said Alt R. There we go. Thank you. Oh, it did do it. It was just delayed. So these are our grid stoppers. So the grid stoppers are just what they are. Same for everything else in the amp. But we're using these for the output tubes. So I'm just kind of placing them ahead of time here. Now we need our pentode. That's what we're looking for. And then we start from the bottom. Now we're here. Control C, Control V. I wonder if it's going to eventually... It's starting to give me guff now. All right. I'm probably going too fast. I'm going pretty quick. All right. So these are our pentodes. Now a pentode would be anything like a 6L6, 6V6, EL34, etc., and it just has all the components kind of written in there. Now on a pentode, we don't really worry about this G2 here or G3 or whatever the hell they call it. Excuse me. So this lower one here, the one very closest to the cathode, is actually the well, that's the grid, so that's the important one. And then the screen grid is either this one or this other one up here. I think it kind of just depends on which tube it is. This one doesn't tell you like number-wise which one it is. I just use these ones here off the back. Again, you just have to remember when you're actually building it. Usually this one up here is tied to the cathode. Usually. Not always, but usually. So this one here is the screen grid, generally. Unless I'm like going crazy and totally have no clue what I just meant, but I'm pretty sure I got it right. Anyway, let's double check and make sure that everything is right here. I want this one to go down one. And let's see here. That is on that plane, that is on that plane, and this is in the middle now. That is good. I like that. This is going to work. Then we can do this here. We're going to take that, move it back a little bit. We just want to give ourselves some space. And then this one needs to come down one, which means this one needs to come down one. There we go. So now we got a little bit of space. Now we can start drawing everything out. So let's, again, kind of recap what we just did here. I will be putting in a master volume in this amp. I'm not going to draw it in because it takes up a lot of space. I know that it's going to be there, and I know that it needs to go in there, and it will go in right in here somewhere. It'll probably actually go in before the tone control does, but in either case, it's going somewhere in here, and it'll basically just interrupt the signal coming into the tubes, power tubes, and then shunt it to ground, and then you turn it up as you need it. Basically, when I'm done, when you turn it all the way up, it is out of circuit, and it's like it doesn't exist. So we're going to draw it as if it doesn't exist, because I know where it needs to go, and I know it's going to be there. So that's all that matters at that point. Okay? So I kind of want to make sure we got enough space in here for some other networks. So we got that. But now what we need is something else. We want two things. We need another capacitor. So this is going to be our bias resistor or bias capacitor, bypass cap for the bias circuit. Excuse me. And I want to do an Alt V. I want that to come out the bottom. And then we're going to put our resistor. And I probably should have put this one in first so it would be R17, 18, 19. But whatever. Doesn't matter that much, to be honest. So this guy we're going to put here. This guy we're going to put here. And I hope this is kind of making sense what I've got going on here. Right? It should make some sort of sense. And it make a little bit more sense here pretty quick. So I'm actually going to do this because we haven't done anything yet. I just want it to be in order. So we're going to put you back there. Ta-da. All right, you're going to go up one. And you're going to go up one. So there, now it's 17, 18, 19. Makes sense, right? Much, much prettier now. Okay, so let's start closing some of this stuff up here. So the reason I didn't do what you think I should have done yet is because of how I was talking about how you kind of got to be careful how you put all these things together. Otherwise, it's very difficult to make a new line and connect it all together. And I wasn't kidding, because it gets really difficult. There we go. And then we got this one. It's going to go to there. All right. Then this one's going to go up to there. And then this one's going to go to... no, I need to do something else here. It doesn't matter, but it does matter. It doesn't matter because it doesn't, but hold on. We're going to escape, and then we're going to go... I want that little guy, right? Oh my goodness, you little brat. It won't let me collect it. Let's see if I can... There we go. All right, I was able to control Z out of that. All right, what I'm going to do is move this over one more, because this guy here needs to go to there, and then this one needs to go to here, and then that needs to go up to there. There we go. Now we're talking. Now we're cooking with some gasoline. All right, now we also need a ground connector. There you are. We're going to go click Alt-R, and we're going to move this guy up into here. This is going to make a lot of sense really quickly here. I'm going to move it in one. All right, so we're going to connect these two together, and then we're going to connect this one to that. Oh, no, we can't do that. All right, escape. Because here's what we want to do first. Dang it, see? This is what I'm talking about. It's not as intuitive as it seems. So these guys here need to wrap around and connect to each other that way. And they need to do the same thing over here. Click, right? They need to do that. But then how do you connect a line to all of these together, right? So we're going to do this, and then we're going to do this, and then we're going to do that. See how I did that? Very clever, wasn't it? All right, so that's how we were able to lock all those in together. We're going to have to do a similar thing here. Now, this is for the cathode, so this is the cathode of this one here. And so what I'm going to do is this, and then I'm going to wrap it to there, right? Makes sense? Now what we're going to do is kind of the similar thing here. We're going to come up, over, around, like so, up, and then in. Click, right? Everything kind of connecty, happy. Makes sense? And we get our grids going in. So this is our bias circuit right here for our output tubes. Now we need to put in another transformer. So I want to find the right one here. And I'm pretty sure the answer I want is this one here. Now why do I want this one here? Because it's got basically a center tap in there for me. We need the center tap. That's this guy right here. So the center tap is going to go to our B node. No, excuse me, our A node. My apologies. So we're going to Control C, and we're going to come over here and Control V that guy, and then we're going to Alt R that guy around like so. Move it up and in, and then connect it. Oh, you dirty little. There it goes. All right, sorry I say that a lot. It's just, sometimes it's just really frustrating. And then we're going to move that A right there. All right, so this should work. Now we need our plates to go in. So we're going to have them go like that. And same thing, same here. So we got our plates coming in and going like that. All right, so those are our plates. Now we need to tie the grid, the screen grids together. Now there's a couple different ways we can pull that off. So, let's see here. How do I want to explain it? You can either use a single resistor or a resistor to each one, or you can use one resistor to both. I don't think it really matters either way, as long as the resistor has enough resistance for both of them. So if you want 1K for one tube, you probably need to use a 2K for both tubes. If you want 470 for each tube, then you need a 1K, right, for both tubes, right? If that's what you're shooting to go with. So that is something you have to decide. Now, there is some argument about how well the screens talk to each other, right? So there is some interplay with those screens, because as, you know, as one tube is going positive, the other is going negative, which means the screens, in theory, should be doing opposite things, which means that you can tie them together and allow them to interact with each other a little bit more. Whereas if you use a resistor for each one independently, they do not crosstalk as much, which means they're going to be more independent of each other. How much of a difference does that make in the operation of the amp is up for debate. I cannot say with certainty that it makes that much of a difference, right? I can just say that it is a factor to consider. I am going to use one for each because that's typically what I do, but let's go to here and you kind of see what I'm talking about. They don't even use one at all, all right? They're simply relying on this 5K resistor right here to do all the work that is needed for that B node. So you kind of get what I mean. Like there's a multitude of different ways you can do it. None at all, one for each, or one for both. All right, so I'm going to keep it simple. I'm just going to do one resistor for both in this case here. All right, for no other reason than. So I'm going to put this guy right there, and then I'm going to put the B node. So we're going to go Control C and Control V, and I'm going to move this guy right in there, and I'm going to move this guy down 1. There we go. So I can get this guy just a little bit tighter. We like it nice and tight. So I'm going to use one resistor. So that's our B node. So then this guy here is going to come over, and it's going to wrap into there. And then the same with this guy. It's going to come up and tie into there. So there's our B node. There's our A node, right? So we've got one resistor that feeds both screen grids, etc., so on and so forth. And I think that's going to work out just dandily. Oh, it sounds like my neighbor's home. She's a cool chick, man. Such a cool chick. She like rain or snow, man, she'll ride her bike. She does not care. She's a beast when it comes to that. I'm a little bougie these days in my old age. I don't ride like that anymore. I used to ride like rain or shine, but not so much anymore. All right, so I'm just kind of encapsulating this here. This guy is gonna go. How do I want to do that? Actually, you know what? I'm gonna escape out of this. I said I'm gonna escape out of this. We're gonna take that one. We're gonna delete. I'm gonna do this. Boop. And well, it doesn't really matter to be honest, but I'm just being nitpicky. So I want it to go like that. There it is. All right, and then we're gonna take this guy, Control C, Control V, and we need to move it up, and it's gonna go right there. Sure, why not? Click. All right, so C node. This is everything that's in the C node. We have a capacitor right here, right? So these two here separate this section of the amp. So everything in here, I missed one. This guy here needs to actually come over and go in. But I know right now I'm not going to like it because, yeah, I'm not doing that. Hold on. Hold on. Stop it. Stop the cap. There we go. Hold on. This is what we're going to do now. So we're actually going to delete this one as well. Bloop. So just to keep it in continuity here, that is where we want that to go, and click. There we go. Now we're cooking with gasoline here. And then these guys will go like that. Now we can take this ground here. Control C, Control V, and then we'll put it somewhere in the middle. We're going to put it right there. All right, and then we're going to connect it up just like that. Now it's connected, and let's see here. Yeah, perfect. Perfect. All right, so everything within this circuit is enveloped for that node C, right? Does that make sense? So that's why I enveloped it that way. Everything on this side of the circuit, I'm not really worried about that much because they're all on this thing here. So this capacitor network here separates the cathode from this side of the circuit, or from that side of the circuit, excuse me, and everything else is powered by this node is in this circuitry here. It probably doesn't matter all that much, but that's how I prefer to do it. So that's how I did it here. All right. we have now built this amplifier. This is the schematic for it. It is complete. And you know, I could be a super jerk and do something here. I wonder I do. I love how it did not move that up with it. Hold up. I told you there's a little bit of leeway that you can get away with on some of this stuff, but I'm going to do this. Will it let me? Yes, it will. I think I can go down one more even. Oh, yes. Oh, yes. All right, so now what we can do is move this back over to here, and that technically lines it up, but it's not right still. But I'm just trying to make it look more uniform like the rest of the thing. So that is on the same plane, and that is on the same plane. I don't like how it's doing it there though. So watch, what I'm going to do here is this. So I need to select the one I want. We're going to delete that out, and then we're going to take this one and delete that out. Then what we can do is this. I guess it isn't going to matter. So here's what I'm going to do. I'm going to take this one, and we're going to go like this. And click, and then bam. Right? See that? Then we're going to take this guy, and we're going to go shooting for the middle here. Let's right here, I think. Click. There we go. See how that worked? There we go. Now everything's more better. I feel like that's more symmetrical, I guess is the word for it. The world has settled in my life. Mostly. All right, so we got everything to fit. Now what I want to do is see if I can get all this stuff, yes, to move down a little bit. So creating some space there. All right, there we go. Now we are ready to start labeling all the values of these things. Now, luckily, when we did this, because I changed these values over here, I only had to change the 6 of them because all the rest are now correct. R1, R2, R3, R4, 6, 7, 8, 9, 10, 11, 12, 13, and then it should be 14, 15, 16, 17, 18, 19, 20. And then let's go ahead. It really doesn't matter how you do it per se, but I'm going to do it from here this direction. So it makes sense. The B node is here, right? And this is feeding the B node. So we're going to make this one R21. All right? Just because. It doesn't matter just so long as you pick one, right? You just got to kind of pick one. We don't need 2 2s. We only need 1. 22, and then this one will be R23. So whether you went 21, 22, 23 that way or the other way, it doesn't really matter. And then for the capacitors, we're going to kind of do the same. So we ended on what is essentially C9, and it kind of moved it like way down here, of course. I'm going to put that up. Dang it. I just cannot win. Right there. All right, so we got C9 here, so this one will be C10. And then we'll do C11. And then 12 and 13, right? 12. And then I think I got that right. C9. Yeah, that has to be right. Because everything else. So we got C1, C2, C3, C4, C5, C6, 7, 8, 9. Yep, that is correct. All right. I just sanity check. Sanity check. 13. All right. So there we go. So now we got all that. So the last thing left for us to do, technically, at this point, is to put a value for everything. So let's go ahead and start doing that. Now, again, I'm going to tell you right off the bat that I'm using generic values for everything. 9 out of 10 chance it'll work just dandy, but I'll give you some explanations for some of them here in just a moment. So you'll notice I'm going with the 10K here. You're like, but doesn't everybody use 68Ks or 33Ks or something like that? Well, this is a parallel triode that I'm doing here. Now, I think the technical value that you need to worry about is at 22K. At 22K is where that's where it kind of just works out. So you don't have to you don't have to go higher than that, but most of the time they do. So Fender shoots for about 33K per thing, right? Well, if you want to get technical, because this is a parallel triode, I'm stumbling a little bit here. I got a little distracted, but a parallel triode has double the Miller capacitance, and because it has double the Miller capacitance, that means that it has twice the amount of high frequency roll off, which means you need half the amount of value that you would normally have. So if 22K is enough for one triode, 10K is enough for two, right? Makes sense? So that's why I went with that value. So let's keep on moving down the line. I'm going to try not to take up too much time here. But I'm just going to throw standard values out here. I'm more than likely not going to use those values. So do be mindful of that. And I will do the proper nomenclature for the capacitors. So I will put 25 UF. And so this one here is going to be a 250. That's normally what I end up with. And I'll do PF, appropriate. I want to do the appropriate values. And then this one here, I'm just going to put 0.022 UF. If you're not sure what value capacitor you want to go with for a coupling cap or any other kind of, well, general signal path capacitor, if you're not sure what value to use, just go 0.022. You cannot go wrong. It'll work. At least it'll work. That's all you need to know, is it will work. All right, so we're gonna go with a 1 meg here. I'm not gonna put log or linear in these. I know what they need to be. What you need to know is that, generally speaking, for tone controls, you will go with linear, and for audio or volume controls, you will go with audio. 2 meg, a lot of people are going to go, why are you going with a 2 meg there? Isn't that going to mess things up? The answer is no, because of the way this circuit works. When this thing is in circuit, this is out of circuit, and vice versa. And when it's out of circuit, the other way, it's bypassing it altogether, so there's no noise penalty for having a 2 meg resistor in your path. And because I'm not connecting it to ground, there's no shot noise either. So, clever way for me to get what I want. I do not know what value I'm going to use here, so I'm just putting a generic value, 220K. I may put a treble bleed or treble bypass cap over the top of this. I do not know yet. This is our grid stopper to prevent blocking distortion. Sometimes you need 220, sometimes you need 470, so it just depends. So I'm just going to put a value there. I don't know if that's what it'll be or not. Same goes with these. I put 1.5K. They can be anything from 39K up to as low as 470 ohms. So you just kind of got to pick a value and run with it. You just never know what it's going to be. I don't want 250 UF. I want 250 or 25 UF. All right. And I love how it always just kind of stuffs it out there in no man's land. Again, I'm not sure what value I'm going to go with here. I'm going to guess that this place right here is going to end up with something more like a 0.0047. Something like that is my guess. I do not know for a fact yet what it will be. Another thing I can tell you is I'm doing the standard values here, 56, and we'll put 56 up there. I'm almost 99.99% positive that will not be the value that I end up with there. And you're probably going, well, what are you going to put there then, Luke? Well, there's a calculator that you can go to online. Cathodione phase inverters work a little bit differently in that they you want to try to get like a 33.33% split for each thing. So you want 33% flowing through the tube, you want 33% flowing through this resistor, and 33% flowing through this. That means that you may end up with two totally different resistors to get that value. There's a pretty cool site. I cannot remember what it is off the top of my head. I'll have to find it. But as I recall, one of these ended up being like an 89K, and another one of these ended up being like a 33K to get what I was looking for. Don't quote me on it. I'm just saying that is something. Fender used generic values, very, very generic values. I am regurgitating those generic values. So just be mindful that there is technically a correct value to use based on the voltage that you have. And I cannot tell you what it is. I do not know. At least off the top of my head. Same goes here for this bias resistor. Generally, you want to go as low as you can, but 1.5K is a perfectly fine thing to use. You can use a 1K too if you want, but you can't not use one. You have to have one there, but just something to consider. And look what the frick happened over here. Why did it do that? That monkey. Hold on. Must fix. There it goes. Now it's right. Sorry. I squirreled there for a second again. All right. So again, not sure what value I will use here. But I'm probably going to go with 0.022 UF for these guys here. I don't know. Honestly. Technically, they're supposed to be 0.01. Or 0.1, excuse me, in... that's what they normally put, but I don't know for sure that's what I'm going to use. This is going to be a 250K, and bloop. And then this one's going to be a 0.0047. I know that one will be that value. Excuse me. And then that guy's going to go... I want to put it like here. Yeah, that's going to have to... No, that isn't going to work. Now you kind of see why I was trying to build some space on stuff. Now, these guys here, there's kind of a practical limit to how small you can go or how big you can go. It's based on the type of tube. Generally, 220 is as high as you will go, unless you're using an EL84. If you're using any of the large bottle tubes, 220K or lower. And you can go pretty much as low as you want to. It's basically a volume control. But you just need to know that there is a practical limit to how big you can go in conjunction with the grid stoppers. So let's say you wanted to put a 20K grid stopper here. You're getting right close to the limit of what you can do. You can only do about 250 on each of those. No, I'm sorry. If you had another tube over here, if you had four 6v6s, this would double up. So you wouldn't be able to go much bigger than a 10K, and you'd start getting into trouble, which means you would need to drop these down more likely down to like 150K. So just be mindful of that kind of stuff. Look at the spec sheets. They're there for a reason. I'm going to go with 5.6K because that is a more appropriate value to use in these positions here. When you're using 1.5K, it's not really doing anything. So why are you doing it then, right? So I'm going to put 5.6K, and I said 1.5K, and then I wrote 1.5K, of course. I'm going to put that there. There we go. All right, so this one here is going to be, it's supposed to be a 250 ohm, so I'm going to put R for ohm. That needs to go, oh, you dirty little thing, come on now. Oh my goodness. Are you not going to let me? There he goes. All right, there it is. All right, and then C9 is going to be 100 UF. Again, you can use whatever value you want there, but just know that there is something that needs to go there. All right. And that essentially takes care of all that. Now all that's left is these guys here. So I can tell you that the first one is going to be a 47 UF. The second one is going to be a 30 UF, I believe. The last two, sorry, that was me making fart noises on accident. The last two are going to be 22s. All right. And then these guys, what are they going to be? I'm going to start with 1.5K. Might be higher, might be lower. Don't know. So just be mindful that you need to run through that calculator and figure that out. There are online calculators to figure out how to factor voltage drop over a resistor. So I'm going to say that this one's going to be a 10K at least. At least a 10K. And same for this one here on the end here. It's probably going to be at least a 10K. Maybe smaller, maybe lower. It just depends. Objectively, I'm trying to get slightly higher voltages over here than what's in the schematic. And now that we have everything done here, we are complete from A to Zinc. let's check out the schematic and kind of just do like a little sanity check, if you will. Talk a little bit about why I don't know how they got that voltage there. But so they're saying that they're using a 340-0340. I can almost tell you that they are not, because if they were, let me see what that would be. 340 times 1.4. It would be like 476 volts on the HT rail, which means that they would have to drop nearly 100 volts through this rectifier. I don't think they're dropping 100 volts through that rectifier. I think the highest one out there only drops like 60 volts or something like that. So that would be quite the stretch. So, I don't think so. Let's see here. I'm sorry, I'm trying to move along pretty quickly here. I'm going to use a 300-0300, which, as we know, will result in about 420 volts right here. And that should put me realistically, after a GZ34, should put me realistically about 380 right in there on this node right here. So very, very close, within about 10 volts of where they're at. And that's pretty realistic, I think. I think in reality, I ended up with about 370 some odd volts on the plates after going through the power or output transformer. So that obviously is based on a couple variables, but right in there. Now, why did I go with the 300-0300? Well, I did that because it got me with a GZ34 to the voltage that I want. Now, it's also just happens to be the same voltage about where this amp normally would run. But if you use a more or less efficient rectifier tube, you will get less voltage. So if you put a 5U4 in this amp, you would have less HT voltage, which would then mean that you get more of a browner sound, right? That, earlier breakup, etc., etc. So it allows you to play around a little bit without exceeding what this amp is actually capable of dealing with. And when I say capable of dealing with, I mean that the 6V6s, once you start getting up over about 400 volts, I kind of feel like you're running into the danger zone. Realistically, they're not really meant to have more than 400 volts on them. I kind of feel the sweet spot's right around the 380 mark, 350 to 380, right in there. Too low and they start getting a little, what's the point of using them, right? And too high and you're just burning them up to burn them up. One thing you will notice about all of my amps is that my tubes don't burn up the logos on them. They're not working like that. They're producing roughly the same kind of wattage as any other amp out there, maybe a couple watts less. But because they're not really working so hard, they're not burning things up. And that's the same kind of principle that I'm shooting for, is just it does the job without having to work to do it, right? So that's why I do things the way I do. So if you want it to be a browner sound, right? Darker, not darker necessarily, but if you want it to break up sooner, you can put in a 5Y3 or a 5U4 and you can get an earlier breakup, right? It's just that simple. So it gives you options still, I guess is the word I'm saying. Now, moving on. They're using a 22K here for this next dropper, but they're using one node for both tubes. Now, do keep in mind, excuse me, I apologize. I need to end this video, more or less what's going on right now. But, so we're using a node for each tube. So that's another thing that's different, is that, this one here potentially could have a little bit of noise, from grounding, and also because it has less filtering. So they're shooting for about 244 volts on these last two nodes here. I want to say that mine will end up more like 300-ish on this first one, and probably 320-ish to 330-ish on this node here. Again, not 100% certain. That is something that we have to play around with. I do not know yet. That's why I say these values here are probably going to change. So, I talked about it with the Atlas that I needed to maintain voltage down the line here, and that's why I used a choke in this position. And the reason is that in the Atlas, I'm using much larger tubes, right? I'm using KT66s now in this case, which is essentially double the wattage, right? So it has more HT draw. So I went, with the 6v6s, if I had 380 volts right here, well, with the KT66s, I have less than that. I can't remember exactly what it is. I think it's like 360 or 350, right around there. So I'm like right at that voltage that is kind of ideal, like the safe ideal place for most tubes, right? 350 volts, right in there. So if that's the case, that means everything else down the line also has that much less voltage. So if I want 300 volts on this first tube out here, very difficult to do without getting enough, inline resistance for the dropping nodes. So that means I needed to maintain, sorry, I didn't mean to plosive on you, but I needed to maintain as much voltage here as I could for the remainder of the line. So that's why we did that. So instead of dropping, 10 or 20 volts here, it dropped maybe a couple volts, and then I used an inline resistor here to get the remainder of the drop. And then for these other two here, I come off like normal, but I had 350 or 360 volts here. Well, I still have 350 or 360 volts here, which means I can get the drop that I need without using too small of a value, right? Keep that kind of stuff in mind. So little things like that. That's how this is going to differ from a 5E3, I can't think of the term off the top of my head. Principally, though, it's going to be different. So I'm taking both of these guys here and basically running them in parallel. I am going to use a 12AX7, just FYI, so it'll be two 12AX7s and then the 6V6s. So a little bit different. 120 volts is what they are expecting to actually sit on the plates. Realistically, even with about 300 volts here on this node, in this 100K here, I'll probably still only end up with about 140 to 150 volts on the plates there. It works a little bit different when you start using parallel triodes. In theory, I should be using a 56K. I usually end up right around 100, but you can go up as high as 330K here if you really want to spank things down the line. Here, again, it's the same. It's just a regular triode, so you can use any value you want right there. If you want to go with 330K, you can do that. If you want to go down to as low as 10K, you can do that. If you go lower here, it will drive this tube a lot less. So you get this tube to start breaking up, but its output is lower, which means it'll help keep this one a little bit cleaner. So that's how you can kind of do some gain staging. But when you go down here, you got to figure out what you're going to do here as well. So, you got to go with your load lines. Yeah, there's always a thing that you got to do. All right. So that kind of answers it. Now, the reason I liked doing why I do the tone control late in the game is I really like having non-interactive tone controls. I don't like things where you turn it one way and it alters the bass and the treble, or you turn it the other way and it, whatever, right? And in a lot of cases with most amps, you turn a bass knob and it alters a portion of the way the high frequency works, and vice versa. You turn the high knob and it does something to the bass control as well. Some of them work like that, some of them don't, but I like having non-interactive tone controls, which means no matter what you do to this, it doesn't do anything to the highs, right? And same goes here. You can turn this down until it's a darker sounding amp, but the amount of bass that's actually being amplified through it is the same. So that keeps the tone control separated. That is a me thing. You have to do something different. I'm just teasing, of course. But again, just some of those other little things that I mentioned are things to keep in mind. Having a grid stopper here, what you're going to do here. Maybe you want to put a 470 in there and then use a treble peaking cap to help get some more highs amplified through there. I didn't put like a treble bleed cap over the top of the volume pot here. you can do that. You can still put a grid leak here. You probably should, technically, is to add another grid leak of some sort to make sure that if this thing ever goes open, that this tube doesn't run away. If this tube loses reference to ground at all, it can start to go into meltdown mode. So things like that are other little safety nets to think about. I don't always do it because I don't always worry about it, but obviously if this pot starts to go bad real quick, you're going to know something's up. So you're going to obviously turn the knob until it starts making noise. As long as the amp's making noise, you're good. So that, right? The biasing resistor here, again, caveat emptor. Just because you see the value doesn't mean that's what it's going to be. So be prepared. You're going to want 280 ohm if this thing's running too hot. You might want like a 200 ohm if it's going to be, if you need it to run hotter. Maybe even a 220 ohm if you can find it, if you need it to run hotter. So again, you need to have some values that, are on either side of that to make sure you can actually bias these correctly. When I bias this amp, it's a cathode biased amp. I'm shooting to get these at about 90% of plate dissipation. Or 95, percent of plate dissipation. Not any lower than 90% though. Anything below 90% of plate dissipation in a cathode biased amp, don't do it. I'm just saying. So all those kind of little things all kind of tie up, and I did not put a value for that guy. Let's do that right now. We're going to put 1K. So that puts me at 470 ohm for each one, right? I can play with this one if I need to. You can go with 2K. More or less, you're just looking to get the screens below the plates, which is kind of helpful because in this case here, you got a 1.5K there already to help with that. So I like at least 10 volts below the plates. But anything between 5 volts and about 30 volts below the plates is okay or good. In some amps and some circles, they have a different idea of that. At the very minimum, I shoot for 5 volts lower than the plate for the screen grids. But I ideally shoot for something between 10 volts and 25 volts. I kind of feel that that's just the magic spot. So just that is me thing. Yeah, again, you might have a different idea. Whether it's right or wrong is up for debate. It's really not up for debate. It doesn't matter. It's a you thing at that point. So getting back to these grid stoppers and grid leak things, you need to watch the tubes. 6v6, if I'm not mistaken, is 500K grid to ground. So that means if this is ground and this is the grid, you can't have anything more than 500K between that point or those 2 points. Otherwise, the tube can go into runaway. It needs some amount of distance between the grid and ground in terms of resistance in order to maintain its bias. So generally speaking, you're going to see about 220K in most all amps. But technically, in most, it should be a little bit lower. 150 to 100K is okay. It works more like a volume knob at that point. That's why a lot of them try to push it up, I think. When you think an amp is loud, it's not loud because it's actually loud. It's just loud because they didn't attenuate anything, which means it gets loud. The tube's still going to do what it does. It's going to break up when it would normally break up, and it's going to do all the same stuff it would normally do. But you're running that tube a little bit hotter because it's got more snot coming into it, which means it is going to start working a little bit earlier. So little things like that. I tend to not push my luck here. I like using higher than normal grid stopper values. 1.5K I mentioned earlier is kind of pointless. It's just there to say it's there. Most tubes will tell you what it likes to have on the grid. And 5.6 is generally right around where it starts. Some even like as little as 10K or prefer 10K. So when you start getting up to 10K, you really have to start thinking about what you're doing here, especially if you're in a 4-tube amp. So when you've got 4 tubes, you've got 2 per thing. These things double in basically. So if you have 250K, that is the same as having 500K on each tube, which is dangerous because you're right at the limit of what is allowable for that pair of tubes to operate. Again, you're pushing your luck. So that's why you generally will see lower values in tubes that have or amps that have 4 tubes. So I think I kind of got all the particulars down. Let's just kind of do a quick recap. Again, I start my design with the power section first, even though I label all the values for the parts last. And then I finish or complete the design from the input to the output. But I like R1 to be the very first resistor that the signal touches, not the power, the signal. And then I continue on. It doesn't matter what direction you go. Honest to God, it does not matter. Just pick one and go with it. That's all that matters, is that you can figure it out. And if somebody else were to look at this that has no idea what the heck they're looking at, can extrapolate it. That's the idea. They can look at this and make sense of it enough to be able to go, okay, I can do something. All right. So I think we've kind of beat that dead horse. It probably doesn't hurt to have a reference schematic around, even if it's not what you're going to be following. It's just got to be something that kind of is similar in design to what you're doing, so you can reference back just to make sure, like, sanity checks. It's really what it's for, is sanity checks. Little things like what the value here or there is. What is this output or power transformer doing? What kind of voltages am I looking for? What kind of values on components am I looking for, etc., etc. All that kind of stuff. That's what it's for. So there you have it. So now let's go back to me. All right. So there you have it. I think we kind of got everything figured out. We've just breached about an hour and 15 minutes, so pretty long video. But you can kind of see what goes into doing it. I wanted to do it in real time so you can really see what it's like to do it in real time. We're going to do the same for the layout. I know this is probably not fun. If you make it this far in the video, you are a super trooper, and I appreciate you. And you probably always get the best nuggets, I think, because you're actually sticking around to the end where all the good stuff is usually at least in my case, I feel. In this case, I kind of went over all the good stuff earlier on. We talked about the raffle, etc., and what the plans are with this amp. If you are interested in what we got going on, please do leave a comment in the doobly-doo below. Spread the word a little bit. It would be kind of cool to get some more interaction on these things. I know I don't typically get a lot of comments on my videos, which is just fine. And I found that the average user only watches about 15 or 16 minutes of these things. So you're missing a lot of the good stuff. A lot of the data and stuff that you probably actually need to know, you're missing out on. So I don't know. That's a you thing. I can't help you there. I told you 100 times, I'm boring. I'm not that interesting. But we're here to try to show you how to do this stuff. So I think with that, we're going to call it. I want to thank you so much for sticking with me. We'll see you in the next one. Take care. Goodbye.